guys, it's probably fairly normal. Here we go. Letter B. What's going on to the original function? What transformation? Shift? What kind of shift? Okay, hold on. Matthew said up 4. Someone else help me out. How did he know it was up, down right away? Jason. Good. It's on the outside, therefore it's vertical, so then he knew it was up, down. And then how did he know it was up? Someone else besides Jason or Matthew? Joe.
It is positive, it's up.
Because on the outside, it's what you expect. It's positive, you go up. It's negative, you go down. No big deal. So we're going to go ahead and do a vertical translation. We're going to think a vertical shift up 4. Now help me out. If you're going up 4, what's wrong? What's wrong? Okay. Stretching, you're fine. Pause. If you're going up 4, who are you changing? The x's or the y's?
Y's.
Oh, okay. So the x's stay the same?
Yes.
All right. So then we just do y plus 4. So what do we do to every single original point? You add 4 to what? The y's. So this point is now going to be negative 4. Got it. So we're just going to move it right up here. This point is going to be negative 2. 2, because negative 2 plus 2. Negative 2, 2. This point's going to be, it's a negative 2, yeah. So we're going to go up 2, up 4. Now some of you are just like, I'm going to go up 2, up 4, up 2, up 4, up 2, up 4. That's okay. It's not bad. But if the points get tricky, maybe this little formula will be helpful. Okay? And then 6, 2 is going to become 6, 6. Got it. Dun, 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 dun. Wait, connect it. Dun, dun. Okay. Are we getting the idea? Yep. So we're practicing all of our transformations in one huge example, and it's awesome. Then you'll be able to do number 10, hopefully, even easier. How about the next one? Letter C. Pause. Not Jason, not Matthew, not Joe. Ooh. Vertical or horizontal? Vertical. Why, Priscilla? Oh, you said horizontal. Who said vertical? Jordan. See, you guys said at the same time. Struggle. Jordan, why vertical? Okay, hold on. We had guessing going on. Does anybody have like a why it's a vertical for sure? Tyler. It's outside the function. See? Now be more confident. Whenever So we have a vertical. Now, hold on, pause. I'm going to give you the hint. It's a dilation. Dilation is either a stretch or a shrink. Who can tell me whether it's a stretch or a shrink? Why?
Well, no, wait, no, sorry, it's a stretch.
You're just trying to read me.
No, I know.
Okay.
I know when it's a fraction, it's a shrink because it's under 1. So above 1, it's a stretch.
And why is Jordan just saying what naturally comes to her, like, oh, a fraction is smaller and a number is bigger? Because it's on the outside, and outsides are expected. It's what you expect. If you multiply something by 2, if you multiply the money in, do you guys have bank accounts? Maybe not. In your piggy bank? Whatever. If you multiply that by 2 on your credit card, if you multiply it by, that doesn't have money. Anyway, debit card? I don't know what you guys carry around. What do you carry around? You just Venmo everybody? Debit? Okay. So debit actually hooks to an account. An account has set number, like amount of money, right? If that doubled, yes, you have more money. Okay, so expected. Expected. It's growing. Sorry, it took me forever to get there. Stretch. By a factor of, well, okay, by a factor of 2. We're multiplying by 2. Okay? So, what can I do with my point? Got it. You guys agree? The x's stay the same, the y's get doubled. Cool. Not Matthew, not Jordan, not Tyler, not Joe, and not Jordan, or not Jason. Yes, go ahead.
Whenever we take our test on this, are you gonna like will you ask for like, is it like vertical, horizontal, stretch, or shrink, or like any like the word part?
Well, let's put it this way. In a multiple choice question, I could have a function in the question, and the multiple choice are like the wordings of it, so you would need to know how to match, or I could have the wordings of it, of what it should be, and you have to match a proper function. Okay. Is that cool? Yeah. We still need to do the points, but let's go ahead and do them. All of our x's are going to stay the same. It's still going to be 6, but instead of 6, 2, it's going to be 6. Actually, everybody can do this. 6 what? 4. I'm doubling the y. Good. Instead of 0, negative 2, it's going to be, don't go up. Multiplying by 2 would make it negative 4, right? What happens when I double that y? Same thing. Negative 4. What happens when I double that one? So what's going to end up happening? Hopefully what you thought it would. A vertical stretch. Ooh, where's my original point? 0, negative 4 is not there. Sorry, anyone who was like, what is she doing? I was stretching that guy. 0, negative 2 would be right there. There we go. That looks better. Whoosh. You see how I'm running out of space? Hence why I make another graph. But Jordan, go ahead.
I didn't see the A example. What exactly did you do?
Oh, the A example, since there was a multiplication of a negative on the inside, instead of being vertical, it was horizontal. Since it was multiplication of a negative, there was a reflection. Technically, horizontal flips a reflection in the which axis? So I flipped all the x's signs. So instead of going 6, 2, I went negative 6, 2. Does that make sense? Okay. All the y's stayed the same. All the x's just were opposite. Yeah. Affect the x if it's a negative. Multiply by negative. Okay, so now coming back to my not Jason, not Joe, not, all of these are J names. Not Jason, not Joe, not Jordan, not Tyler, and not Matthew. Those aren't J's. What's going on in D? Give me one. There's 2 things going on. Hopefully you guys can see. Yeah, Joe. Yes. See how I had to think about it? X-axis reflection is what kind of flip? Vertical. And why did he say a vertical flip or reflection in the x-axis? Because there was a negative. Got it. Okay. What else? Got it. Shift 4. Okay, now hold on. Let's think about our sample point. So vertical flip, what's going on with our y? Like each of our y's. Anybody can answer. What's going on with our y's? They become negative, or you could think opposite. Is that okay? They don't become negative, they multiply by a negative. So they become the opposite sign. So all the y's are going to flip signs. And then what's going to happen to all of our x's?
They move to the right.
But how can I show that in like a formula?
+4.
X plus 4. You guys see it? And if it's helpful to you, you can make little tables. And you can make little tables where you take each of these individual or these beginning 4s. You can actually do that for this entire problem. You can make, hey, what are all my x, y's of my original function? You could list them all out. You can say, okay, I have negative 4, 2. I have negative 2, negative 2. I have 0, negative 2. And I have 6, 2. You could take it one at a time. You could be like, what happens with f of negative x? Okay, well, letter A, I'm going to be doing negative x, y's. Change them all. 4, 2, 2, negative 2, 0, negative 2, negative 6, 2. You could do letter B, and you could do your next one. You could say, okay, this is going to be x and y plus 4. You could list them all out. You could do your next one, letter C. See what I'm doing? You don't even technically need to look at the graph at all. You could just play with the points. And some of you might think that's only for number 10, but you could do this with any parent functions, also playing with the points that are in the parent functions. Okay, so what am I going to do? Flip all of my y values to be opposite signs, and the x adds 4. So I'm going to add 4, 0, multiply by a negative, 0, negative 2. Oh, that's funny. This one, I'm going to add 4, 2. I'm going to multiply by a negative, 2, positive 2. You could also think if you actually like by hand moving points, you could take this point, 0, negative 2, and you could say, hey, you're shifting right 4, and you're flipping up. You could also do it that way. You don't have to use this little pattern. Could do that with this point also. You're shifting right 4 and flipping down. So whether you do the math to the points, point by point, changing the x's how they need to change, changing the y's how they need to change, or whether you're just thinking of this whole thing needs a shift and then flip, both ways work. Okay. Not Jason, not Joe, not Joe, not Jordan, not Tyler, not Priscilla. Who did I miss? And not Matthew. I wasn't looking. What transformation is going on in E? I gave you guys an easy one. Nehemiah, what's going on? Got it. Shift down 3. Can you keep going, Nehemiah? What would your point be? Make your representative point. Got it. What happens to the x? Stays the same. X and y minus 3. If it's just a down 3 vertical on the outside, what you expect? It's a minus going down. All the y's will subtract 3 and the x will stay the same. So is it cool if I say 2 minus 3 is negative 1? 2 minus 3 is negative 1. Negative 2 minus 3 is negative 5. Negative 5. Got it. The aforementioned list plus Nehemiah. Don't talk. F. F. Give me a transformation. Alfredo, what's one thing going on in F? Why do you say in the x-axis? Everybody, why do you say x-axis? Vertical flip. Good. So vertical flip, there's a negative on the outside. But good, good, good. In the x-axis is the proper way of saying it. Alfredo, can you finish it off? What's the other transformation? Got it. Shift down 1. Let me pause and you guys try to make the representative point. Not that that's going to be a test question, but it might help some of you. Having a little pattern. What pattern would you put for a vertical flip and shifting down 1? What do you think? Do you agree? How could we check and see if we're right? I mentioned it yesterday, I think really, really briefly, but some of you, they were easier yesterday, so maybe you didn't realize how helpful it could be. Joe, you were answering this when I was like, does it matter the order? Because now we have 2 different things going on, and both of them are affecting the y. Yesterday it didn't matter. Today it does. Because yesterday it was a change to the x and a change to the y. They didn't really clash at all. It was okay. But today we have to change, and here's the idea. Ready? Either you flip and you go down 1, and the graph ends up here. Or you go down 1 and you flip, and the graph ends up here. So the order does matter. Do you flip and go down? Or do you go down and then flip? How could we check? We could check by plugging in a point. And we could say, all right, what's going on if x is equal to 0? If x is equal to 0 and I have negative f of x minus 1, I could go ahead and say, Joe, just give me a second, okay? But thank you for volunteering. I could say this point right here, where does he go? Is he going to be flipping and going down, or is he going to be going down and then flipping? I could just plug in 0 and say, you know what? I don't know. What's going on? Plug in 0. Who's f of 0? No. F of 0, isn't that the function value or the y value at 0? Who's the y value at 0? negative 2. So this is going to be negative 2 minus 1, which will be positive 2 minus 1, right? And positive 2 minus 1 is 1. So I need the point 0, 1. So 0, 1 says the flip should go first and then 1 down. Good. That's just like a little backup if you weren't exactly sure which to do. The nice thing is actually, isn't that the same order that we read it? But if you're thinking if it's all nice and simplified out, everything's distributed, you can work, in a sense, left to right with the multiplication and then the addition subtraction, kind of like PEMDAS would say. Multiplication, division, then subtraction, addition. Anyway, we are going to go ahead and flip first, which is what we did. We made it negative 2 times negative, which is positive 2, and then down 1. So we can do each of these. Negative 2, flip it, is positive 2, down 1. Positive 2, flip it, is negative 2, down 1. Then positive 2, flip it, negative 2, down 1. So our point does work. This would have been the proper. And if you guys notice, wait, can't you just replace this with a y? Can't you just replace that with a y? Not too bad after all. Now, sadly, I'm out of colors, so let me go find a random color, and I think I have one right here. Okay, everyone's back in. Everyone's back in. It's the last transformation. Horizontal shrink. You guys are acing it. Why is it a shrink? It's unexpected. So what is it by a factor of? 1/2. I know, right? Not negative. But that's where our the others. So by a factor of 1/2. So how could we make our representative point? What's shrinking? Good. The x's are shrinking by 1/2. The y's are staying the same. And ironically, for a lot of these functions, a horizontal shrink is going to be the same thing. Think of a rubber band. If you push it in, what else is happening at the same time? Yeah, so you could have actually also said this is a vertical stretch by a factor of, well, let's see what happens. Horizontal, instead of going 6, 2, what's it going to be now? 3, 2. Instead of being negative 4, 2, it's going to be, and instead of being negative 2, it's going to be, and then it's all nice and squished. Yep, got it. Horizontal shrink by a factor of 2. Horizontal shrink by a factor of 1/2. You could say divided by 2, or you could say by 1/2 is what you're multiplying. Whew! All right. Does that give us at least a little bit more direction as far as number 10? Okay. But let's review really quickly from yesterday. Is number 10 the only homework problem? No. Oh, yes? That'd be nice. That'd be kind of, well, I don't know if it'd be nice. For some of you, it'd be nice. For others of you, it wouldn't. Let's go back to section 1.7 really quickly. Control F, section 1.7. Okay. Since the entire homework is not number 10, even though that is a brutal one, number 10, in case you haven't seen it yet, a lot like number 9. Can anybody who did do homework last night or who was working on it, can you give me a nasty function from in here somewhere with all the different transformations? In this section right here, if anyone wants to open up your homework spiral. Or just look at it. Is there one of these you're like, I don't like the looks of that one? 27? Where is he? All right. All right. Let me steal him. Is he an actual homework problem? Yes, he is. All right. You don't know, he just looks gross. Okay. I want us to take what we just did. I know it's fuzzy, just ignore it. Okay, I want us to take what we just did. Oh, and it's up on the ceiling, almost. And apply it to this guy. Do I have a graph? No. Do I have points? No. But could I? Yes, because who's the parent function? F of x is just x squared. And who's x squared? He has 0, 0, 1, 1, and 2, 4. Oh, negative 1, 1, and negative 2, 4. Couldn't you talk about the parent function with points? Oh. So could you, if you wanted to, could you do the exact same thing that we just did point by point? You could, if you don't like doing it any other way. Are there other ways? Sure. Negative 2, 4. But let's talk about this. Guys, let's check them out. And we're trying to identify what all of his different transformations are. First of all, do we like how he's written? What would be a nicer way of writing him? Does it mean the exact same thing if I just reorder a couple things? Is the 2 positive in both? Yes and yes. Is this piece negative in both? Yes and yes. Why do you like this one better? It shows the vertical shift clearly. This one, some of you would be like, I don't know. Okay, vertical shift clearly. So let's just list it one by one. First of all, what's this guy? Vertical flip. And as Joe and Alfredo both said, reflection in the x-axis. What's this guy? Unexpected. Wait, vertical. Hold on. We also have a vertical shift up 2, right? While we're talking about vertical. We have a shift up 2, and then we have a shift left 5. Okay. So what would our representative point be?
X minus 5, 5 plus 2, and this vertical flip.
Like that?
Wait, there's vertical flip. So it should be one of them
Because vertical would be changing the y's. Horizontal would be changing the x's. Now, could we double check? Sure, totally. How can we double check? Take a point, 0, 0. Easy. Do xy. Like say you were on a test, you wanted to make sure that you were right. Couldn't you take 0, 0 and do 2 things? Couldn't you plug into what you think is the proper? And then couldn't you also plug into your g of x and see if they match? If they match, you're good. You're golden. Go for it. So I could say, hey, subtract 5 from 0. Cool. Negative 5. Multiply the y by a negative. Sorry, that's gross. What's negative 0? Okay, well, that's kind of lame, but there we go. Negative 0 is 0 plus 2. Got it. And what happens if we plug in to the beginning? 0 plus 5 is 5. 5 squared is 25. 0 plus 5 is 5. 5 squared is 25. 2 minus 25 is?
No, actually we should plug in the negative 5.
We should plug in the negative 5? Why?
That's the x value.
Good. This is a point for which function?
The standard.
The original function, right? So we have to be careful. Good, Joe. We have to be careful as to what point we plug in. Once we get this point, then we plug into g and say, do you work? Do you work? Well, we would say plugging in negative 5. Negative 5 plus 5 is 0. 2 minus 0 is? Got it. So we'd have to plug this into the transform, see if it works, and then we can go ahead and plug that into the original equation and say, do you work? And when you get the check mark, you're ready to go. Just in case you wanted a way of checking to make sure all of this was correct. So what do we do piece by piece? We shift to the left, 1, 2, 3, 4, 5. We flip the y, which doesn't go anywhere, and we go up 2. And we have our point right there. We could also go ahead and take this point, 1, 1. We shift to the left 5, which would be negative 4, 1. And then we have to flip the y, which would be negative 1, and add 2, which would be positive 1. Now some of you realize there was no vertical or horizontal stretch, so maybe you realize these points are going to kind of come along with. Maybe some of you guys could shift this whole thing left 5, and then flip, and then go up 2, so maybe you could pretty quickly get this point. And without too much work, you could go ahead and figure out this is going to end up being negative 2. There we go. So there are ways to kind of shortcut the process, but using our little reference point or our little guiding point, that would help with every single point if you needed it to. Do you guys see how we can apply this to hello to all of our parent functions if we need to. Do we have to? No, but do you need to at least be able to figure out what all the different transformations are and to do them? Yes. Are we tracking? Section 1.7. Done, 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 done. Let's grade it tomorrow since some of you don't have it done. Section 1.8. Here we go. Let me bring it down so you guys can see it. Those of you that were ready to grade homework, awesome job. Those of you that weren't, it's okay. Just if you were stuck, take what we did today in class and persevere. Take what we did to class and persevere. Dig in. Use examples in the book as well. Use CalcChat to guide if you're doing the odds correctly or incorrectly. And hopefully tomorrow, because of what we did today, we'll have fewer questions. Sound good? Okay. Section 1.8. Nice thing is we technically have today and tomorrow on 1.8. There are so many places common mistakes can happen in 1.8. There's new notation. And there's so many poor little animals that are in danger. Specifically puppies and seals. Maybe a few kittens. Mostly puppies and seals die in this one. No, it is. It's a travesty, which is why we have to be super focused to watch out for them. Combinations of functions, specifically leading up to compositions. But this is hard from the very, very beginning. The math isn't hard. The math is easy cheesy. Could have showed you this in Algebra 1. Maybe I did. But the notation is hard. The math is easy. The notation is hard, and the little mistakes you can make are so, so, so tempting. Or I should say so, so, so sneaky. Here's Dilio. The beginning of all of this just says, hey, can you add, subtract, multiply, and divide? And we all say, hopefully, yes. Although if I was to give you a 2-column multiplication or a long division, you would all groan. But oh well, you've been seeing it for a long, 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 long time. Addition, subtraction, multiplication, division. So what makes it hard? These do. These do. Unusually cold. It's because the air was on when you guys walked in. I'm sorry. Here's a struggle. Actually, I'm feeling pretty good. Oh, I have like a little baby. I don't know. They just took out my material that used to totally block out the sun up there. And so the sun has been shining in all morning. So my hypothesis, to figure out how it works, my hypothesis is it's heating up the room and then it's triggering that and it's turning on faster. But right now the sun's not shining in, but it was a little bit ago, and my poor thermostat in here, if anything can explain it, it's delayed reaction. It takes a while to turn on, it takes a while to turn off. But it's not currently running, which means it's going to warm up. Yeah, it wasn't bad, right? Oh. Okay. The big thing I need you guys to have for today, or to figure out for today, or to know for today, the difference between of and multiply. Have we talked about of and multiply before? Have we talked about of and not multiply before? And the answer is yes. Remember what I said was going on as soon as we do something like this? How do you read that bottom one? F of 3. I put that's so basic for some, and it's so complicated for others, depending on how your brain works. Some of you are so used to memorizing things and just having F times. Maybe you know F of, but as soon as you see this, you're like, F times 3. You're going to have a horrible time today unless you get down those formulas that are highlighted up there. Because this is F of, not F times, and that's exactly what we need to expand on. Make it a little bit trickier today. Because this is not F plus G times X. But, oh, it looks like it, doesn't it? It's F plus G of X, which means F of X plus G of X. As far as which side you're going to actually be doing, it's the second side. Let me get my highlighter out. This is how to solve. 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 These are just notations. Joe.
Is that a dot or is that a time? Like time
This is a raised dot. That's a comma. It's comma like for inequalities and piecewise functions, like a such that. Does that make sense? Sorry, there's a little tail, but you guys can't see it so good. So well, that's better. This is how to solve. This is notation. So I need you guys to go ahead and make a note somehow to yourself. This is just oh, highlighters don't like writing, I forgot. Undo, select. There we go. This side is just notation. It's not telling you the math. It's just telling you the notation. Now, it is telling you addition, subtraction, multiplication, division. True. But it's function notation for linear combinations of when you're trying to add 2, subtract 2, multiply 2, divide 2. So when you get over here, and if it asks you for F plus G what X? That's what it's asking for. What do you need to remember? F plus G. One more time. F plus G. Does that make sense? Not multiply. And in a little bit when it says something like, hey, let's find F plus G. Oh, tell your brain no. It's F plus G of 3. So use this right over here. How could you rewrite that in that notation? Or, I'm sorry, how could you rewrite this notation as to what you're supposed to actually do? It's just F of X plus G of X. The math is so easy. Just take F, 2x plus 1. Take G, better put parentheses, just in case it was a minus, poor little seals would die. It's not a minus, so seals probably wouldn't die in this one. Now here's something that will be very helpful for homework. Listen carefully. As soon as you can, put a pencil down, or at least stop it from moving and look at me. Why am I about to keep going? I can simplify. I can combine my terms. No big deal. What if I was to do something, now what if, really different problem, what if I was to do something like this? Why would I not keep going? I can't get, but I want to. No, you can't. So if that was there, I'd be stuck. But since it's not there, what can I do? Combine like terms. Ready, set, go. Combine like terms. I'll do it too. We'll check each other. Should be good. Yeah, that good? Could you rewrite that, like factor out an x? Sure, why not? But are we good? The math is easy. What's hard? The notation. So this guy, how could I rewrite this notation in what I should actually do to solve? F of 3 plus G of 3. Bless you. How do I do it? Just like I showed on the board. Take the 3 and put it in the input spot, which is right up here, right? Think of it as a box like we did before. Think of it with parentheses like we did before. F times, who plus 1? This time 3 plus 1. Plus, that's for my F. Yeah, my who squared plus 2 times who minus 1? Plug in my 3. Then I just have to be really, really careful with PEMDAS to say, okay, exponents first, so I have a plus 9. Now I can do multiplication division, so I have my 6 plus 1. I have my 6 minus 1. Some of you might be like, hey, the 1s cancel, the 6s are 12 and 9 is 21. How could I check my answer and make sure that I'm right? I've done it a totally different way. Yeah. Couldn't I have also said, oh, hey, it's this guy when x is 3? We already found f plus g of x. We could have just plugged in 3. Let's double check it's right. Does 21 equal 9 plus 12? Dun, 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 dun. Sweet. Now what if they make it a little bit harder? Now pause. Eyes on me, real fast. Why would it be harder if they just made it a minus and not a plus? Right away, why would it be harder? When you put the minus, you need to remember to distribute that to everybody and not kill a poor little seal, or 2 or 3 or 10. Okay, so the minus makes it harder in and of itself, but why is division even harder? What if I was to give you something like the same f and the same g, but now I was to ask you for, first of all, don't get confused by the notation. What does it say? What am I finding? Good. F divided by g of x, or like Joe just went straight to the f of x over g of x. Okay. So how would I do it? Easy, right? Yeah, some of you guys are going straight to the domain problem, but first of all, just plugging in, wouldn't I just take f and take g and say no big deal, right? But some of you were like, there's a denominator, so if I see domain and if I see a denominator, what am I supposed to remember?
It's not 0.
It can't equal 0. Because if you divide by 0, it's an undefined number. So domain problem, back from chapter 1a, domain problem. Denominators can't be 0. Radicands have to be positive, greater than or equal to 0. And logarithms, we haven't really seen them yet. Arguments have to be greater than 0. Wait, how do I find the zeros?
Set 0.
Who equal to 0? You can't set anything equal to 0 yet. Factor. Hopefully for most of us, this would be easy if we just tried. Ooh. Is that good or bad? That is bad. Because a negative times a negative is a positive, and a negative 2. Plus. Positive is. How could we solve for the zeros? Your favorite. X equals negative b plus or minus square root b squared minus 4ac. Heroes. A negative times a negative is a positive, which would make it into an 8. Are there zeros? Yes. Are they pretty? No. When would there not be zeros? If you had an imaginary number. Ooh, let's just cancel out 2s and kill kittens all over. No, don't do that. But what we could do is we could say, wait a minute, isn't root 8, doesn't he have a perfect square? Oh, he could be root 4 times root 2. So I could make it negative 2 plus or minus 2 root 2 all over 2. I could legally, without killing kittens, simplify out a 2 because everybody, don't take it out of the root, has one. After all that work, domain. X cannot equal negative 1 plus or minus square root of 2. Long story short, though, when you divide, a denominator can't be 0 and have fun finding his zeros. Hopefully the factors are nice. And if they're not, use the, what's it called? That thing I just did that was a song? Quadratic formula. If some of you need to, maybe you should write down x equals negative b plus or minus square root b squared 4ac all over. Some of you spoke it. Good. Scott Uyukawa was in a, second year engineering math course, and he said we had to use it, and I was saying it. I was like, good job, buddy, good job. Okay, so I had him in Algebra 1, 2. Some of you guys don't know him. This is a sad day. Are we done? No. What do we have to do tomorrow? This thing called a composition. And who is he? A composition says, What if you have an f with an open circle, g of x? How do we do that? Bye, guys. See you tomorrow. Just think of, not multiply. Killing me. Bye, guys.